Hello, this is Dr. Bahauddin Abdullah and this is section 11.5 alternating series. By alternating series we mean series with this term -1 to the power n minus 1. So the first term would be positive, the second term would be negative, positive, negative, and so on. Or the first term could be negative, positive, negative. So it will has always this term -1 to the power n minus 1 from 1 to infinity times bn. Now if bn sets, this is an, all of it an, but if bn satisfies these two conditions, bn plus 1 is less than or equal to bn, this means that bn is decreasing, and the limit of bn is 0 when n goes to infinity. If bn satisfies these two conditions, we say that the series summation an, all of the series, the alternating series, is convergent. Otherwise, we don't know. We shall see. Let us discuss some examples. This is the first example. Summation -1 to the power n minus 1 over n. We know that 1 over n is the harmonic series, so they call this the alternating harmonic series. If n is 1, it would be -1 to the power 0, so it is 1 minus half plus 1 over 3 and so on. The alternating harmonic series. It is an alternating series, so we always use the alternating series test. This test is specially designed for alternating series. So let us find the limit of 1 over n. The limit of 1 over n, bn, what is bn here? It is 1 over n. So forget about -1 to the power n minus 1 and concentrate about 1 over n, bn. Limit of 1 over n is 0, and bn plus 1 would be 1 over n plus 1. n plus 1 is greater than n, so 1 over n plus 1 is less than 1 over n. So bn plus 1 is less than bn, so it is decreasing, bn is decreasing. This series satisfies the two conditions, so it is convergent by alternating series test. Another example, this series, this is bn. Let us find the limit of bn. The limit would be 1 over infinity, which is 0, e to the power 0 is 1, n is infinity, 1 over infinity 0, so the limit of this of bn is 0. It is not easy to prove that bn plus 1 is less than bn here, so we can prove decreasing by finding the derivative of f of x. Let us find the derivative. X squared is the quotient, the numerator, the derivative of the numerator, e to the power 1 over x times the derivative of 1 over x. This is the derivative of 1 over x, -1 over x squared, times the denominator minus the derivative of the denominator, which is 1, times the numerator, e to the power 1 over x. Now, x times 1 over x squared would be 1 over x. And if you take -e to the power 1 over x as a common factor from the numerator, it would be like this. So this is always positive, e to the power 1 over x, and this is positive multiplied by negative. X squared is positive, so in fact this term is always negative. So this function is decreasing always, so bn is decreasing. So it satisfies the two conditions, so this series converges by alternating series test. This series converges by alternating series test. Another series, it doesn't seem from the beginning that this series is an alternating series, but if you find some terms, you will find that if n is 0, it is sine pi over 2, which is 1. If n is 1, it is sine 3 pi over 2, which is -1. If n is 2, it is sine 5 pi over 2, which is 1. So you will find, in fact, that sine n plus half pi, 1 minus 1, 1 minus 1, it is -1 to the power n, exactly. If n is 0, it would be 1, then -1. So sine n plus half times pi is exactly equal to -1 to the power n. So you can write this series in this form, and it's clear that it's an alternating series. Limit of Bn is 0, and it's easy to see that Bn plus 1 is less than Bn, so it's decreasing. So the series converges by alternating series test. Another example. This is an alternating series. Let us find limit of Bn. Limit tan inverse when n goes to infinity is pi over 2. It's not 0. Okay. So alternating series test fails here. But what can you conclude from here? Well, I can find the limit of this sequence of an. If you multiply arctan by negative 1 to the power n minus 1, so the limit would be positive or negative pi over 2. The limit is pi over 2, but if you put negative 1 to the power n minus 1, so it would be either pi over 2 or negative pi over 2. But this is not 0. So the series is divergent according to the test for divergence. Test for divergence says if limit an is not 0, then the series is divergent. Another example. This is a series which is written like this. The terms are given. Negative, positive, so it's an alternating series. So let us forget about negative 1 to some power and concentrate about the numerator. Look to the numerator. 2, 4, 6, 8, 10. 1, this is the first term. 2, the second term. 4, the third term. So in fact the numerator is 2 times n. What about the denominator? This is 1, 5, 2, 6, 7, 3. So this is n plus 4. So this series can be written as negative 1 to the power n, 2n over n plus 4. If n is 1, it would be negative. This series can be written in this form. It is an alternating series. Limit of Bn is 2. So limit of an would be positive or negative 2, which is not 0. So according to test for divergence, this series is divergent. Good luck.